Finding vertical asymptotes. By definition, if the limit as x approaches a of f of x is either plus or minus infinity, either the two-sided limit or the one-sided limits, then the line x equal a is called the vertical asymptote of f. So we're going to analyze the following limits to find the vertical asymptotes. So the limit as x approaches 7 from the left of f of x. So if we look at a chart and pick values to the left of 7, like 6.9, 6.99, 6.999, we see that the values are going off towards negative infinity. So the limit as x approaches 7 from the left equals negative infinity. Okay, along those same lines, let's pick values slightly larger than 7. So the limit as x approaches 7 on the right is positive infinity. That means our two-sided limit does not exist. So we have a vertical asymptote at x equals 7. Now let's try 0. Here we can just evaluate well, if we evaluate, we're going to get undefined. So let's see if it's the same on both sides. So I'm going to do a table, pick some values slightly less than 0 to the left and slightly greater to the right of 0. Okay, so it would be to the left and then to the right. So it looks like on the left and right hand sides of 0, the function values are going towards negative infinity, so the two-sided limit would be negative infinity. So we have another vertical asymptote at x equals 0. Okay, so find all the vertical asymptotes. X equals a of the function, and for each value determine the limit. Okay, so we need to look at the domain, so we need to factor f of x. So in the numerator we could take out a greatest common factor of x. Same thing in the denominator. And then factor the numerator again. Okay, so remember when the numerator and denominator share a common factor, that's where you have holes. So there's a hole at x equals 0 and x equals 8. So since the numerator and denominator have these two common factors and there's no additional factor in the denominator that would make the denominator equal to 0, we have no vertical asymptotes.